Hello everyone, this is Angelo. Welcome to today's live stream. Had a great day yesterday. I don't know if or who of you went to the Haas demo days. It was a lot of events going on across the country, and we were there, 33 different HFOs. We were showing fusion and machining on some Haas machines. So it was quite cool. We had the whole Autodesk gang there. It was awesome. So today what we're going to be covering is soft jaws and the basics of creating them and setting it up and properly machining it. So let me switch over to the screen. And so today, here it is. It's super basic. I'm not going to get too complicated. So let me show you over here. So I've done some pretty complicated setups with soft jaws, but today we're just gonna keep it simple, modeling the jaws in Fusion and cutting the pocket into the jaws like that, and then showing you how to machine that. So nothing too complicated, nothing fancy, just keeping it basic, starting at the entry level here, so all of you can follow along. And then in future live streams, what we'll do, we will get more advanced. So what I'm going to do, so if you guys are familiar with the Kurt vise, what you would have is the soft jaws in there. And let me hide some of these. So you basically just have the soft jaws here, and they would clamp on your part. So as a machinist, when you machine your soft jaws, you want to clamp on something in between the two vise jaws so that they don't move and that they're in the position they're going to be in when you're clamping onto your part. So what I do, it's very common to just clamp onto a parallel, and that parallel is 1/8 of an inch thick. So I actually modeled that parallel, and then I modeled the soft jaws, and I brought them in a small assembly here. So I'm going to go through step by step and show you guys how to do that in Fusion. Alright, so I'm just going to start a new design. And the first thing I'll do, I will create that parallel. So I create a sketch. I'm going to create a rectangle. And the thickness, or the width of that parallel, is 1/8 of an inch, and then the length is 6 inches. I'm going to finish the sketch, and now, actually, should I close that? You guys can see just fine. All right. So now I'm going to extrude that, and I'm just going to extrude that up to 1/2 inch. I will now save that. I'm going to call that parallel. Again, I'm just creating these one by one and saving them. So you can see there's my parallel. The next thing I'm going to do is I'm going to create my jaws, my soft jaw. And I'll create another sketch. Create another rectangle. And the width here, I'll do, it all depends on what you have. You can create your own soft jaws. You could purchase them. So I usually just make them myself so I can control the size of it. So let's use 1.5 inches here. And the length, we'll do 6 inches again. And we'll finish that sketch. And I can pre-select that, hit the letter E for extrude, or come up here. And let's make that 1.75. And now what I'll do, I'll save this, and let's call this soft jaw. And these can be made out of aluminum or steel, whatever you desire. I usually make them out of aluminum and have a bunch on the shelf on hand. So I'm not going to worry about putting the holes in to accommodate a socket head cap screw or anything. I'll just keep it simple like this. So now what we have here in the data panel, I've got my soft jaw, I've got my parallel, and actually here's the part that we're going to be bringing in. So some things to remember. Let me switch over here. So if you're clamping on, so here's that part that I actually made. So when you're clamping on that, you need to take into account some things. So if you have some tight radiuses, you need to create some clearances and whatnot. So let me switch over. I created some samples. If I go over here, one moment. So if I have a part here and I want to put this pin in, and let's say that the diameter of this pin is 1/4 inch and the hole is 1/4 of an inch, the pin, there will be interference. So what you want to do, you want to make this feature here a little bit larger to accommodate the pin. So I'll take that another step further. If I go here, same thing. If you want this square part to fit into here, you want to have a little bit of clearance between the walls, between this wall and this wall, right? So again, it depends on what you're doing, the size of the part, obviously many different scenarios, but I just wanted to bring this to your attention and just get you thinking about creating soft jaws and how to hold the part. The next step here, what I did is I created this, and now I have some clearances in the corner to accommodate for the sharp corner of the part, this edge here. So again, when you create a soft jaw, you're just creating a feature like this to accommodate your part. So soft jaws look just like this, and then again, taking it one step further, I created this. So this would be one soft jaw, and that would be the other soft jaw, and then you would be able to clamp your part in there. So those are some things that I wanted to bring to your attention and get you, like I said, get you thinking and how you're going to hold your part and how you're going to orient your part. Those types of things are very important to consider when you're creating soft jaws. So here is the assembly that I created, and let me show the part. And so there's the part nested in the soft jaws, and let me hide the part, and I created let me hide the original soft jaws and put in the soft jaws with the pocket. And so what I did is I did adaptive roughing to clear out the material, and then I did a pocketing operation to finish the floor. I left material on the wall. Then I came in with a 2D contour and machined around the wall. So let me hide the stock, and I can just simulate the end mill cutting around the finished contour. So what we're going to cover today is how to get to this point, how to get all of this in here and create your setup and create your toolpath. So let me go over here. So we've got the soft jaw, we've got the parallel, and this was some of the parts that I just had in my hand. So I'm going to create a brand new assembly, or a new design, I should say. And I'm going to import, I'm going to bring in this parallel, insert into current design. And you see this here? I just opened a brand new design. I tried to insert this parallel by right-clicking, and down here on the bottom right, it says, error, please save this design before inserting. So I need to save this first prior to bringing something in. So I'm going to say soft jaw live stream. Okay, I'll save that now. So now I've got a check mark there, and now I could go ahead and right-click here, insert into current design, and I've got my parallel. I'm just going to leave it there and hit OK. So the next thing I'm going to do, I need to now bring in my soft jaw. So I'm going to right-click here. I'll insert that into current design. And now I can move the part around. I'll drag it away from my parallel just so I have some space. And as I drag around, you can see this number here updating. So you can type in numbers. I just like to drag it and just place it there for now. We'll come back to that. Again, I'm going to bring in the front jaw. Insert that into current design. I'm going to drag this away so I have some space. I'll hit OK. So I'm going to do a couple of things here. I'm going to break the link. So you see there's this link here. It looks like a chain link. That is linked to the original design. So if I were to make any changes in the original design, it would update here in the assembly. But in this case, I don't want that to happen, so I'm going to break the link on all of these. And finally on this one. What I'm also going to do is take care of some housekeeping. So I know that this, so if I look at my orientation here, so if I'm standing in front of the machine and I'm looking at my vise in this orientation, that's going to be the rear jaw. So what I like to do is to do some housekeeping, and I'll just say rear original jaw. And then on this one here, I'll call that, double click that. And I'm going to call that front original jaw. And when I get into my machining setup, you'll see where this, where it's important, or not important. It makes my life a whole lot easier. It'll make your life a whole lot easier if you do some proper housekeeping. All right. So now what I need to do is create a joint between this jaw and the parallel. So this face touches this face, and then move this face touching that face. And there's many ways to do assemblies. I'm just going to keep it simple here. I'm going to create a joint, and I'm going to see when I move my mouse, when I hover on this face, it has that coin, and I can hover near the point, so I want it to be there. You want to be careful that it doesn't, if I rotate around here, that it doesn't, the orientation doesn't move on you. So I'm going to click that face there and that point there. I'm going to drag this guy here, and now Fusion creates a rigid joint. There's all kinds of things we can do here. For this demo, I'm just going to keep it at rigid. Hit OK. So now we've got the rear jaw joined with the parallel. And do the same thing again here. Create a joint between this face at that point and this point right there. Again, Fusion remembers my last one was a rigid joint, and I hit OK. All right, so now we've got our soft jaws in place, in contact with the parallel that I would physically clamp in this orientation on the machine. Again, so when I machine the pocket to accommodate the part, that these jaws aren't moving around. Obviously, the rear jaw would be stationary on a Kurt vise, but the front jaw is movable, and you don't want that moving, so you want to clamp it. And it's very common workflow to just clamp on a parallel, since we have those laying around in front of the machine. You can use anything you want. I like to use parallels. So next thing I need to do, guys, is to bring in this sample part. So I'm going to right click on that, and I'm going to insert that into current design. Fusion brings it in, and I can click on these arrows and drag it. And pay attention here in this area. You can see the numbers are moving. I can move it this way. You can put it wherever you want. So what I'm going to do, so I can look at it from the right, and I'm going to drop this guy down into here. You can get very precise by typing in numbers here, whatever you like. You can go -0.5. Yeah, that's not enough. Let's make that 0.625. That looks good there. So now I hit enter. So now we've got our rear jaw, we've got our front jaw, we've got the part in place, and we've got the parallel right there. So now I'm ready to start doing some things to cut away the material to accommodate the part. Again, remember what I said earlier, guys, is this link. I'm just going to break that link. And we'll cover more of that type of topic in further live streams. So now what I'm going to do, there's a few ways, more than one way actually I should say. So It's very similar to if you ask someone about directions. Hey, how do I get down to the local grocery store? You can say, go down the street, take a right, take a left, and then go straight for a bit, and then take another right. And if you ask 10 people how to get from point A to point B, they'll give you different ways to get there. So same thing here on this. When you're doing stuff like this, there's many ways to create soft jaws, and this is just one way, and we're going to be covering more in further live streams. So I'm just showing you one way right now. All right, so we've got everything here in place, and what we need to do, a tool I'm going to use today, it's under, when you're in your design, under the solid area here, we've got modify, and you've got a tool here called combine. I actually have it here on my, I have it docked right there. You can hit, so what you do, you hit combine, and then it asks for a target body and a tool body. So let me simplify some things here just for visual purposes. I'm going to cancel out of that. And what I'm going to do, I'm going to hide this front jaw so we can see things clearer. So that's our parallel, that's our soft jaw, and there's our part. So now we want to cut this shape into the soft jaw. So I'm going to come back here to modify, combine. Again, what my target body is, my target is the jaw. So I'm going to click that. And if I rotate around, you can see the part is not, the part I'm machining isn't selected yet. So that's the tool body. So I can now click that. And if you think of a Syncer EDM where you create a part that will generate a shape into another part, so it's very similar process. So when you use this combine tool, you select the target and then the tool that is creating the shape. And then under operation, you've got some options here. Join, cut, or intersect. I want to cut into that target body. Other things I like to do, I need to create a new component, and I want to keep the tool. So after I cut, I want to keep the part there. So I'm going to hit OK now. And so now what Fusion did, you can see down here in the timeline, we've got the combine down there in the timeline, and it created a new component. And then we still have the original rear. So now if I hide my part, the sample part, so that you can see, so we've got the original jaw is this, and then we've got the new component is that. They're kind of sitting right on top of each other, so I'm going to hide the rear original jaw. And look at the result of the part that we have here. So again, if I show the part, it cut into the jaw, but where these holes are, like that face and that face, it left material in that jaw. So what do you do in that case? So I'm going to keep it really simple. And here in Fusion, so I can click on that face. But what I'm going to do, I'm just going to do a press pull. What I'm going to do is I'm going to remove all these bosses sticking up. So I'm going to click on this face, catch that one there, catch this one here, and here. So you see I've got 6 faces selected, and I've got this arrow. So now I can drag that down. But the cool thing about Fusion, I don't even need to know the number. I can just click on that face, and it'll offset that face down to the selection I created, and I'll hit OK. And just like that, I've got the shape into my soft jaw to nest my part properly. So again, we've got the original jaw is there, and then this is the new one. So I'm going to, again, proper housekeeping helps you down the road. So I'm going to say rear jaw with pocket. All right. So now we've got the part there. So we're going to need to do the same thing on the front jaw. So I'm going to hide this. And on the front original jaw, there it is. And if I hide my part, you can see it's the original jaw. So what do we need to do? We need to go here again, go to combine. Again, target body is the target I'm cutting, which is the jaw. The tool body, which is creating the cut, is the part that I'm going to be holding in the soft jaws. Again, I want to keep the new component. I'm sorry, keep tools and create a new component. So now if I hide the part, we've got this, so I'm going to hide the front original. And again, we've got these parts sticking up here. And I'm going to get rid of those with the press pull. I'll select those faces. Again, I can drag. And if I don't know the exact number, I can just click on the face I'm going to. Okay, that. And there we go. So now we've got the front new jaw. So let's name that so we don't, so we clarify things later on in our assembly. So that's going to be the front jaw with pocket. And I'm going to show the rear jaw. So there we are. We've got our new jaws created. And there's our part that's going to nest in there. And we've got our parallel is highlighted right there. So now we've got what we need to start machining. Again, I'm going to hide that part. So we're going to machine this now. So what we're going to do here, actually let me look at the chat, see if there's anything I need to look at. That looks good. Brad's handling all of that. All right, so we're going to go now to the manufacturing workspace. And one thing I just thought of here, my toolbar may look different than some of you guys out there. So here under your name, if you go to Preferences, and then if you go to Preview, under General here, I have UI Preview. Make sure to check that, and then you hit Apply and OK. Then you restart Fusion, and it will come up with this user interface. All right, so going back, we want to now machine the pocket. I'm going to come over to Manufacture. And we need to create a setup. And in our setup, we define what we are cutting and what our stock is and where our origin is for the machine. So I'm going to create a setup. And by default, Fusion just pops up like this. It recognizes some bodies and it creates some stock for me. So what I'm going to do, I need to verify that we're milling. You can do turning or mill turn. We're doing milling today. And what I need to do is verify the model, what I'm cutting. So I need to click this. Now that's blue. Fusion needs some information now when that's blue. So I can click on the part in here. I'm going to show you how to do it just from the browser, just from this area. So the part we are cutting is going to be the rear jaw and the front jaw. Remember I was talking about housekeeping? Now I know what these objects are. It makes my life a whole lot easier for selection. And then the rear jaw original and then the front original, that's going to be our stock. So that's going to be on this tab over here. And you've got some options here. You can do relative size, fixed size, where you define the size. Check this one out, from solid. So I'm going to click from solid, and this is highlighted blue, needing some information. I'm going to select the rear jaw original and the front original. So now it highlighted the pieces of material that were original before I cut the pockets in. And again, I'm back over here, and the jaws with the pockets, that's what I'm going to be cutting. My origin was default set up to this. I can move this point to here. I can move it there. You, the machinist, you have control of that where you want that. I'll just leave it there for now. And then under post-process, this is where you would give it a program number for your machine, and then a comment, cut soft jaws. And then your WCS offset, that would be on your machine, your G54 or G55. So 0 or 1 would be G54. So this would be G54 also. This would be G55, G56, and so on. Let's just leave that at 1 for G54. And I'm going to hit OK. So just here in a couple of minutes, now I'm talking through this, so we're about 20 minutes in. And even talking through this, it's relatively quick to get to this point. And you can see the stock is, there's a slight yellow highlighted representation of the stock. So now what we want to do, we need to machine that. A few ways to do that. You can come into here, into 2D. You can do pocket. You can do adaptive clearing. I'm just going to come here to 3D adaptive clearing. And that, what that does, it looks at the stock and looks at the model. It's very intelligent. It makes your life a whole lot easier by doing it that way. All right, so I'm not going to get into speeds and feeds, but I do need to select a tool. And I can create a new tool. Fusion has all these samples in here. And I'm going to come down tutorial inch, and it pulls up all the tools in there. I could filter now by type, and I'm going to filter to just show me the flat end mills, and I'm going to OK that, and it gives me some tools here. So I'm going to just take this 1/4 inch flat end mill, hit OK with that, and over here, stock contours comes up. I don't even really need that on, but rest machining here. So what Fusion, let me see if I can expand that guy. So Fusion is looking at the source. What are you machining? So if you remember in our setup, we created the setup. We added the stock that we're cutting. So that's what this is looking at right here. The next tab is our heights. So that's your elevation. Where your tool, so your tool will be coming down in this direction, and these are the defaults. It says go to the model bottom, which is this dark blue line here. Start at the stock top, which is this lighter blue line. This is a retract height, and then the clearance height. So what I'm going to do here, just under bottom height, I'm going to click that and come down to selection. And now as I hover around, and I'm going to, you can see the bottom face, it changes color. I'm going to click that. And now here it says bottom reference is a face. It's that blue face. And if I look at it from the front here, remember that dark blue line was down here, model bottom. Now it's up here, which is at the bottom face of that pocket. Another thing to look at and be aware of here in Fusion, stock to leave. So that says how much stock to leave on the walls, which is the wall. That's radially, leave 20,007 inch. And on the floor, 20,007 inch is going to leave some stock there for finishing. So I like what I see there. I'm going to hit OK. Fusion's going to calculate that. And there, we've got a tool path. So I can simulate that now. I'm going to show the stock, and I'm going to rewind. And before I hit play, which is right there, I like to, let's drag this guy out there. I like to show tail. So imagine if this is the tool moving around, there's a tail of the tool path showing off behind it. And under colorization, I usually do material, and plastic vinyl is this color. That's what I usually use. So now I'm going to hit play. And now you can see it machining. Entering the pocket there. And with the adaptive clearing, it's taking a constant engagement and machining that material. Let that finish up. And you can see here we've got some material. There's some material there on the walls, 20 thousandths of an inch, and on the floor we've got material right there. So now what we need to do, we need to go in and finish and clean that up. So I'll close my simulation. And what I'm going to do here, I'm just going to go here under the 2D toolpaths, and I'm going to do a 2D pocket. Infusion remembers the last tool that I used, and that was that 1/4 inch flat end mill. You can select another tool, but for this case, I'll just use the same tool. And under geometry, what pocket selection? What are you cutting? So I'll click this edge, and then this edge. So Fusion, it gives you this blue highlight preview of what it's going to machine. So again, if I deselect that, and if I click on this edge here, Fusion creates that highlighted blue area, and I want to contain it between that line, and I can come over here to this. So that's what Fusion's looking at when it generates the toolpath. The heights, the bottom height, it's already defaulted to selected contour. So if you remember, I selected that contour, which was that edge right there. So I don't need to do anything on the heights tab. But on the passes, I want to verify some things here. On stock to leave, so I want to leave material on the wall. I'll leave 5 thousandths of an inch on the wall, but I do want to finish the floor. So I'll put 0. I'll hit OK here. And so now what Fusion is doing, it's machining the floor, but leaving materials on the wall. So if I come here to my setup, we can now simulate this. And I'll hit play. You already saw this. I'll let that play through just so you can get a visual. And you can see we've got material on the wall and material on the floor. So then the second toolpath that I created, which was the 2D pocket, it's now going to finish the floor, but still leave material on the wall. But this time it's leaving a lot less material. It's only leaving 5 thousandths of an inch. And what I'm going to do now, I'm going to come in with the contour using cutter compensation, and I'll clean that up. So I'll show you how to do that. And I'm going to close this here. I realized I left that open, so just to get some more real estate here on my screen. So now we're going to come in here again under 2D toolpaths. We've got this here, 2D contour. Again, here in Fusion, it remembers the last tool. I can come in with a different tool. I'm just going to use the same tool. Second tab here under geometry, what am I machining? This is highlighted in blue, asking for a selection. I'm going to click this line. I'm also going to rotate the part around and click this line. So now we've got the contour selected. The heights, again, the bottom height where it's going to is to the selected contour. So if I view from here, it's kind of hard to tell, but the selected contour is the contour that I chose right there. And then passes, what I'm going to do in this case, in computer, it will offset the tool here in the computer. But I want, when it gets to the machine, to use cutter compensation. And that way, when I'm at the machine, I can open up that pocket a little bit bigger to accommodate my part to fall into that pocket. So I'm going to select where, and that will output the proper code for your machine using cutter compensation. So that all looks good there. I'm going to hit OK, and it's going to take one pass along that back wall and then along the front wall. So that looks good, but you see we've got, it's two separate contours. How could I fix that here in Fusion? Because remember, we've got this gap of the parallel right there, holding the jaws apart. So where this will actually work. It'll work just fine. But there's some tools here in Fusion. It's very cool and very handy. If you right click, edit that operation, you go under geometry, and right here under tangential extension distance, you can give a value there. And remember that gap was 0.125. So I'm going to hit enter. And now what Fusion did, it bridged that gap, and it did one continuous contour using cutter compensation. But it's also starting and stopping right here. And I would prefer that it start either on this side or on this side here. And so how do you do that in Fusion? I will right-click the operation. I'll edit. And then here under linking, down here at the bottom under positions, entry position, nothing. So see it says nothing. So I can click that. Now it's highlighted in blue. I'll come over here and hover my mouse. And let's say enter there. I'm going to hit OK. And there you have it. Look at that. So now it's entering in this area, arcing on, contouring around, and finishing that. So let's simulate everything. So I'll just highlight my setup. I'll come up here to simulate. And now we'll play the whole thing. And you can see what Fusion's doing. Slow that down just a little bit. So bear with me. There's a slight delay here on the live stream. Okay, so as that's playing, I see a comment there by Sebastian. What is cutter compensation? So cutter compensation, it compensates. So if you buy a tool and say it's a 6mm tool or a 1/4 inch end mill, and you measure it, it's not exactly 1/4 of an inch, or it's not exactly 6mm. You can compensate at the machine to accommodate for any wear on that tool. So if that tool is slightly undersized, you could then cut actually 2 size on the machine. And so you use that, or we machinists use that in the shop to accommodate for things. So say for example this pocket here that we just machined and just created, if we want to open that up, say for example 0.01 millimeters or 0.003 inches, something like that, you would in your machine control go to the offset page, and you can type in a value, and you can actually open up the pocket a little bit larger, because if you have this part and it's not sitting in, like that example I showed you with the pin going in the hole, so you can actually open up a hole or open up a feature, or in this case open up the pocket that the part will sit in. So cutter compensation, it allows when the machine cuts to make the pocket or feature bigger. So we'll be covering more of that in depth, but that's the basics of what cutter compensation does. It simply opens up the pocket or feature that you're machining. So as you can see here in the example, it cut down exactly to the geometry that we created. There's some other tips and tricks that I like to use. So instead of using cutter compensation, what some people also do, you can come into your 2D contour, right click the 2D contour, come into the passes tab, and we were talking about stock to leave earlier. And so again, on the axial on the floor, I want to go right to that floor there. But on radial stock to leave, what I sometimes do, I will just give it a value of something like that. So it's 1.5 per wall, which is an overall. On that pocket, it will open it up 3 thousandths. So then right away when Fusion cuts, actually what I'll do is I'll make this bigger so you can see it in the simulation. I'll give it 20 thousandths of an inch, so it's bigger. So it's going to violate, it's going to cut into the model. So what I'll do, okay that, and then now when Fusion machines, it's actually going to violate that wall and cut in by 20 thousandths from that geometry that we selected here. And I will simulate again. I'll play this, and I'll just click on this contour so it goes right to it. And then now you can see Fusion actually did cut into the model, and because we have the rear jaw showing, let me hide it now. So now I hid that jaw here in the browser, and you can see that the cut, let me go to the top view. It's hard to see with the shadows, but you can see that now this wall is cut further in. And if I show the sample part, you can see there's a gap there. There you go. You see that gap right there? So by using stock to leave, I can control it there to make that pocket a little bit larger. Or I can use the cutter compensation to make that pocket a little bit larger. Now I exaggerated, I made it big on purpose so you can see, but you do want it to be a little bit larger, and it's going to vary from part to part based on the features you have and the overall size of your part. So you want to make sure that after you cut at the machine, let me hide that sample part. So before you unclamp your vise and you remove the parallel, you want to take your part and actually see if it fits. So you want to make sure that your part here sits in nicely. Very similar to what I was showing you guys here. You want your part to fit nicely in there, just like if you have a pin and you want that to slip in nicely. So what I recommend always before, which one was I just working on? Here we go, right there. So before you, it's this one here. There we go. Before you unclamp your vise and remove your parallels, make sure that your part fits. You want it to fit nicely. You don't want any resistance as you drop and place your part into the jaws. So that's pretty much what I wanted to cover today. I didn't want to go super long. I wanted to keep it short and sweet and straight to the point. And what we're going to be doing in future live stream, we're going to do that big assembly where we did this. We actually cut these yesterday at all the Haas demo days. So a few of you probably even seen this part. I did it also last year at the SEMA trade show in Las Vegas and FabTech and performance racing industry shows. So it's a cool little part. We'll be doing some more advanced things in soft jaws, but this was the basics. What I wanted to cover today is how to create soft jaws. Hope you guys got something valuable out of this. And if there's any comments or questions, actually I look at my comments I got on another screen here. It all looks good. I don't see anything there. And don't forget, in August, it's the, what's the dates? 5th, 6th, and 7th. Fusion Academy, all of us will be there. So I'll be there, Brad will be there, Aaron will be there. The whole Fusion team will be there. You'll get to meet us face to face and interact with other enthusiasts and users. So that's about all I have for today. I hope you guys got something out of this. Again, don't forget to subscribe. And if you like this, give us a thumbs up. If you're not thrilled with it, give us a thumbs down. Totally understand. We're here to help you guys. We want to provide you with some valuable content. And leave comments, and I check them out, and Brad checks them out, Aaron checks them out, and we try to get back to you guys in a timely manner. Before I go, I'll take a quick look. Oh, hey, I see a comment there. Can you talk about the order of the cuts, walls versus floor? Daniel, hey, glad you liked that. You're welcome. So last question, why did you use a pocket and a contour? So let me start with Eyal. So I like to, when I did this here, so before I go, I'm going to answer that. So first what I did here is I cleared out as much, let me switch to the screen. So what I did here, in the first operation, I cleared out all the material and I left material on the wall, on all these walls, and also I left material on the floor. And the reason why we do that in machining is because when you cut, there's some deflection. And what I mean by deflection, let me get a pen, or I can start to simulate something here. What I mean by deflection, if this is my cutting tool, and let me see, if this is my cutting tool, and I'm machining around the part, and with the forces in machining, deflection, the tool is going to actually push away from the material you're cutting. If you're climb cutting, it's going to push away. So when you do roughing, there's a lot more force, which creates more deflection. So the distance the tool is being pushed away from the final shape you're trying to cut, it will be more exaggerated. So what we do, a common workflow, is we machine and we leave a little bit of material on the walls we're cutting and a little bit of material like on the floors that we're cutting in the pockets. So that when we come in a secondary operation, or in this case I did a pocket, when the tool machined around that pocket, there's less deflection on the wall and less deflection or less force on the floor and on the wall, which will push the tool away less. So that's the reason why I did a roughing and I left material on the walls. And then when I finished the floor, I still left material on the wall because I wanted to finish that floor so it's nice and smooth and clean. And then the third toolpath I created was a contour. And with that 2D contour is where I'm controlling the size of the pocket so the part can fit in. So that gives me a ton of control to make that pocket bigger or smaller so that the part will nest in the pocket, in the vice jaw. So I hope that makes sense, and I hope that explains the question. Oh, you're welcome. All right, so let me check out the screen, the other comments. So that answers that by Sebastian, and then Eyal answered that. Daniel, thanks again. Everybody, we appreciate all you guys taking part of this and taking out time of your day. We know you're busy with work and life and family and all of your things you've got going on. So we value you guys and the community that we have here on the Autodesk YouTube channel for Fusion 360. So we'll continue to bring you some quality stuff, valuable content, I should say. If there's anything you guys need, don't hesitate to reach out. We're very transparent. Brad's always available, Aaron's available, and I'm always available. So hope that gives you guys something to work on, and we'll continue. Let me show my screen one more time. And we're gonna, so here's that part I was just showing you. Where is it there? We did it in a 5th axis setup with soft jaws, and I did it with some Lang, and I also did it in some Shunk work holding. So look for that, the more advanced work holding. So here's how the pocket looked for this. So there's the part that I had in my hand, and you can see it nested there nicely. So we'll cover how to do all of that in a future live stream. So with that, hope you guys have a great day, and we'll see you guys next time.